Today's lesson will deal with transformations of square root functions. Some of the ones that we have to review are your vertical transformation, horizontal transformation, vertical stretch and compression, and then horizontal stretch. And so, for example, below we have the parent function, which is square root of x, and it says which function moves the graph so that the y-intercept is at point P. So you notice that this graph has to move up. So it's between the square root of x plus 2 and the square root of x plus 2. So here's the difference. So I'm going to graph g of x so you know what's happening. Menu x plus 2. And then the other one is the square root of x, and then we have plus 2. And so you notice that the one that satisfies the question is the square root of x plus 2. That's going to move the parent function 2 units up, which is going to go through P. So the answer to this question is h of x. So we have problem 1. It says, what are the graphs y equals 2 square root of x and y equals negative 1/4 square root of x? So I'm going to graph 2 times the square root of x, and you notice that it's the parent function and it's stretched by a factor of 2. So y equals 2 square root of x is the parent function vertically stretched by a factor of 2. So if I had to sketch it, it would look something like this. Now we look at y equals negative 1/4 square root of x. We know that the negative is going to reflect the parent function and the 1/4 is going to compress it. So y equals negative 1/4 x is the parent function reflected over the x-axis and vertically compressed. And I can do that here. I'm going to go ahead and type in negative 1/4, and then we have the square root of x. And you can see that. What are the graphs of y equals square root of x plus 2 and y equals square root of x minus 3? The graph of square root of x plus 2 is the parent function. Here's the parent function. Shifted up actually shifted up 2 units. And so this is the parent function, y equals square root of x. So what we can say about the next function or next equation, the graph of y equals square root of x minus 3 is the parent function shifted down 3 units. So if I go to my calculator, I have the square root of x, and then I have minus 3, right? So you notice that the function goes down. So it is y equals square root of x minus 3. So it's the parent function moved down 3 units. Next problem we have, what are the graphs y equals square root of x minus 3 and y equals square root of x plus 2? Well, the y equals square root of x minus 3 is the parent function, and it's shifted to the right. As you can see, when I do it in the calculator, you notice it goes to the right. Y equals square root of x plus 2 is the parent function shifted left 2 units. So as you can see, the green here, it's shifted 2 units left. What you have to remember is if it's minus 3, it will go to the right when it's minus. And when it's positive, it goes to the left. It always goes to the opposite. So what I'm going to do is I'm going to go ahead and graph the square root of x plus 2. And you can see how it's shifted to the left. The next one is, what are the graphs of y equals square root of 5x and y equals the square root of negative 1/2 x? Now, if the 5 is in the radical, which it is here, then it will be a compression. And I'm going to go ahead and show you here. And this is called a horizontal compression. So when I say horizontal compression, it means this is being affected left to right. So this is getting closer to the y-axis. So therefore, that's why it's called it's a horizontal compression, and it looks like this. And I do want you to sketch it. So you have y equals the square root of 5x. Now the negative will affect it differently. The negative will reflect it not over the x-axis, but this will reflect over the y-axis, and 1/2 will be a horizontal stretch. So let's go ahead and see what happens here. So we have the square root of -1/2, and then we have x. I know it says x squared, but it's supposed to be x. And you notice that it reflects over the y-axis, and it's called a horizontal stretch. So now we're going to go ahead and put this all together. And what's going to happen is I want you to describe what each of the numbers, how they will affect the transformation, how the numbers will affect the transformation. For example, 3, the 3 in front of the square root, that's going to be a vertical stretch by a factor of 3. The +2, we think it's going to move to the right, but it doesn't. It's going to shift to the left 2 units. So the +2 is going to shift to the left 2 units. The -4 is going to shift the parent function down. So I'm going to walk you through the graph, but I'm going to go ahead and use my handheld here. So here is my parent function. I'm going to subtract 4. And you see I moved it down. The parent function will move down. Now I'm going to add 2, and that shifts it to the left. And now I'm going to place the 3 right in front of the radical, and you're going to see how it stretches vertically. And there it is.